All right, hey, what's up, everyone? Today is another quick problem. Count of subset sum. Count of subset sum. There we go. Yeah. We're going to be using a 0, 1 knapsack DP pattern, and so the problem statement is given a set of positive numbers, find the total number of subsets whose sum is equal to a given number s. So example one, we're given what do you call it? The set of 1, 1, 2, 3. Not sure exactly if we should even consider it a subset or like a set, because we only have we have duplicate numbers. So, but I guess it depends on like what you constitute as a set, right? But then, because the way I think about it is like the data structure set, which doesn't have duplicates, they're all distinct, but it is what it is. So the question is sets. So 1, 1, 2, 3. The sum is 4. Our output is 3. Sorry. The sum is 4, and we have the set. Our output is 3 because there's 3 ways we can create a subset whose sum is 4. 1, 1, 2, 1, 3, and 1, 3. The reason why we have two 1, 3s is because we have two 1s. So this can be a 1, 3 here and a 1, 3 here. Right? And so this is the same for example 2. With this set, sum of 9, we're able to do 2, 7, 1, 1, 7, and 1, 2, 1, 5. So these are the solutions just to keep track for later. And so once again, I'm going to try to go through my solution. So we're going to be doing bottom-up dynamic programming. So this just means that we're going to be using an array. So top-down dynamic programming means you have to do recursive calculations, right? I'm not the biggest fan of recursion, so we're going to use array. So what we do here is we're going to be doing, so we're going to create our array, our 2D array, rows constituting the different numbers found in the set, and columns, rows being, and columns being, what would it be? And the columns being each number we are targeting. So, and then we're going to populate the array with starting information, aka base cases, and then we're going to do and so process the rest of the array and then return our solution here, which is the bottom right index of the array. Bottom right, aka last index of the array. So I'm going to create our 2D array here. So dp is equal to -1. We're going to return -1 if we cannot make a set. -1 if it's just impossible to make a number of that set. So we're going to do -1 for I in range. Actually, we'll just do columns. For column in range of target plus 1, because we need the numbers from 0 through whatever target. And then we're going to do for R in range of length of nums. Right. So that creates our 2D array. Now we need to populate our array with starting information, or the base cases. So for I in range of n, or length of nums, we're going to do for, dpi0 is equal to 1. because there's always one subset that can create a target sum of 0, which is that's just the empty subset, right? And then for, I think I should have done R instead. For the rows, so we can keep that consistent. For C in range of target plus 1, and also we're going to start from 1 because we don't want to overwrite this first index. We're going to do dp 0c is equal to 1 if c is equal to num0 else 0. So basically we're able to create, we're just going to create one. We're just going to have 1 for that number because in the first row, we can either have a sum of 0, which is the empty subset, or using the one number, which is just the number as the sum, and we can't create anything else. And so we're going to process the rest of the array for r in range of length of nums. Oh, we also have to do 1 because we don't want to go through the first row again. For c in range of 1 to target plus 1, because we also don't want to go through the first index. We want to do dp rc is equal to dp r minus 1, minus 1 c. Because this line is because if we were able to create a subset using fewer numbers, we can create the same sum with those same numbers, and then potentially we could use one of our current numbers. We'll use the current number that we're at and make the target, right? So regardless of what happens, we will always use the previous row. But if c is greater than or equal to nums r, then we can then the target could include our number as part of the sum, right? So if c is greater than or equal to nums r, then dprc is now plus equals to dp r minus 1 c minus nums r, right? So basically this means we're able to use however many numbers in that previous set and add our current number to all of those sets to create our target sum as well. So that's why we use the previous row and then we add that. And then so here we're just going to return dp. In Python we're able to do this, -1, -1, but realistically the solution would be length of nums, length of nums minus 1, and also target, right? This is what the actual answer would be, but just to make sure I don't make any mistakes, we're just going to do dp of -1, -1. So if we run this here, we should see 3 and 3, which is exactly what we expected, right? Oh, no wonder it looks off because there's no colon in this one. So if we run it again, there we go. So just to give you, I guess, a better visualization, let's run this with 0, 1, 2, 3, 4. I think that's the first one, right? Yeah, we'll just do the smaller array. And then so we have a 1, 1, 2, 3, right? And so here for a base case, for the first column, it's always 1, right? There we go. For the first column, it's always 1. And for the first row, we want to go through everything. And if c is equal to the number, then we make it 1. Otherwise, it's 0, right? So now we start from 1, 1, as we can see right here. We start from 1, 1. dprc is equal to the last column. So it's equal to the last column. And if c is greater than or equal to the current number, then we take the last row and that value and we add it. So this is actually 2, right? Which makes sense because in order to create 1, we're able to just use this one or this one, and that's two different sets. Even though they're both ones, it's two different sets because we have two ones in our set, so it's a 2, right? So same thing, we take the one above, and then since it's greater than, we go up 1, left 1, because this is the number 1, and then so we grab that number and then we add it, so it's 1, which also makes sense, right? For 2, we can use 2 ones and we'll create a 2. And we go up again, and we go, since we know it's greater than, we'll just keep using the same pattern. We go up, left, 0, 0 plus 0, 0. And then this one 0, go up, left, 0, 0. For this one, 2, we go up to the last column, or like last row. And then since C is 2, oh no, our current column is 1, is not greater than or equal to 2. So we can skip this. Now we go above, and now 2 is greater than or equal to 2. So we now go up 1, back 2, and so there's 1 there. So 1 plus 1 is now 2. So 2, right? Which makes sense because we're able to do 2 here, and we're also able to do 2 here. So now we have 2 sets, or like 2 ways we can make 2, which makes sense, right? And then so now we go up, and 3, can we make a 3? We go back 2. There's 2 ways to make 3, which makes sense. 2, 1, 2, 1. There's 2 ways. And for 4, you go up, back 2. There's 1. How do we make it? 1, 2, 2. That's 4. So we go to the very last one, repeat again. You go up 1, 3 is not, 1 is less than 3, so we just go, 2 is less than 3, so we go, now 3 is equal to 3. So go up, 1, 2, 3, plus 1, so 2 plus 1 is 3. How do we make that? We can do 3, we can do 2, 1, 2, 1, and that makes 3, right? So for 4, we go up 1, 1, and then 1, 1, 2, 3, and add 2. So 1 plus 2, 3. And so how do we do that? 3, 1, 3, 1, 2, 1, 1. Right. So this 1 represents the 2, 1, 1. For the 3, we can do 3, 1, 3, 1, and then the original 2, 1, 1 for the 3. So that's how we get the 3, and that is our solution for this count of subset sum problem. If you have any questions, comments, concerns, please leave it in the comments below. And with that, that's the video for today. Thanks, everyone.